Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, Jest, uh, TIFR, IIT-Jam exam and other exams related to physics. Okay, so it's lecture number 5 of quantum mechanics CSIR net PYQ. So we are going to start, but before starting the class, I would request the people who haven't subscribed my channel yet, please subscribe my channel. And also I thank you the people who have already subscribed my channel. Okay, so we are going to start. This is the lecture number 5 for quantum mechanics CSIR net PYQ. Okay, and let's start now. So we'll start with question number 1. Okay, these all are the questions which are asked in CSIR net exam. Okay, so I'm starting now. Question number first is, let V, P and E let V, P and E denote the speed the magnitude of momentum the magnitude of momentum of the momentum and the energy of and energy of free particle free free particle of of rest mass m. Okay, rest mass m, then options are dE upon dP d upon dP equal to constant Option B is P equal to mv. Option C is V equal to Cp upon root P square plus m square plus m square C square and D equal to mc square. Okay, so this is the question is, let V, P and E denote the speed, magnitude of momentum and the energy of free particle of rest mass m, then which option is correct? Okay, A, B, C and D, which one is correct? That we need to find. Okay, so we'll solve this question now. Solution. Okay, so m is rest mass given, right? So we know for relativistic particle P equal to m dash v. Okay, where where m dash equal to gamma m, where gamma is rest mass. Okay, sorry, my apology, m is rest mass of the particle, rest mass of the particle m, and gamma, the value of gamma is that is 1 upon root 1 minus v square upon c square. Okay, for the relativistic particle the momentum is this. Okay, or we can write P equal to gamma mv, where m is the rest mass of the particle. Okay, v is the velocity and gamma value of gamma is 1 upon root 1 minus v square upon c square. Okay, so we'll put the value. So it is going to be, this is m rest mass, okay, which is already given m. Okay, well, so we'll proceed further. So we'll put the value. So it is going to be P equal to mv upon value of gamma is 1 minus v square upon c square. Okay, the value of gamma is this 1 upon root 1 minus v square upon c square. Okay, we'll simplify it further. So it is going to be squaring both sides. It is p square equal to m square v square upon 1 minus v square upon c square. That implies we will cross multiply this. This is going to be p square minus v square p square upon c square, and this is going to be m square v square. Okay, so now we'll proceed further. This is going to be this one is going to be v square equal to p square equal to p square upon m square c square plus p square upon c square. Simple calculation. Okay, after this, right, so we have find the value of v square. Okay, this v square. Okay, so this is the one we got, and then this is going to be v square equal to p square c square upon m square c square plus p square. That implies value of v is going to be root of this is pc upon root m square c square, pc upon root m square c square plus p square. Okay, so value of b is this one is the answer. So let's check which option is matching. So option number C is the correct one. Okay, that is cp upon root p square plus mc square. This is v equal to pc or cp upon root m square c square plus p square. Very simple question, right? So this is the one, right? Okay, now we will solve question number 2. I hope guys you understood it. So now we are proceeding with question number 2 of this lecture. This is also very good question. The wave function of a state, the wave function the wave function the wave function of a state of wave function of a state 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 of hydrogen atom hydrogen atom hydrogen atom hydrogen atom is given by is is given by is given by psi equal to psi equal to psi 200 plus 2 psi 211 plus 3 psi 210 plus root 2 psi 21 minus 1. Okay, where psi NLM is normalized eigenfunction is normalized eigenfunction normalized eigenfunction of the state normalized eigenfunction of the state with quantum numbers with quantum numbers NLM in the usual notation in the usual notation okay. The expectation value the expectation value of LZ in state psi is option A 15 h cut upon 6 option B 11 h cut upon 6 option C 3 h cut upon 8 and option D h cut upon 8. Okay, very good question. So this is the wave function of a state of hydrogen atom is given by this. Okay, so wave function is given where psi NLM is normalized eigenfunction of the state with quantum numbers NLM in the usual notation. Okay, and the expectation value of LZ, okay, Z component of that L angular momentum in the state psi is we need to find out. Okay, very simple. So we'll start in next page. Solution. Okay, so first we have given psi, that is psi 200 plus 2 psi 211 plus 3 psi 210 these are an NLM value, okay, plus root 2 psi 21 minus 1, okay, this is the given. So we need to find out expectation value of LZ, okay, that we know psi and this eigenfunction psi NLM are normalized eigenfunction, okay. So this we know psi LZ psi LZ psi upon psi into psi, right? This we know the expectation value. So here the value is going to be very important, right? This we need to know sigma I mod square of Ci mh cut, okay, mh cut upon for this value, okay, and this is going to be sigma I mod Ci whole square. Very important formula you need to note down, guys, for getting expectation value of LZ, okay, where Ci is coefficient of psi NLM, okay, coefficient of psi NLM, okay, these one the coefficient for example psi 200 the coefficient is 1, for this psi 211 the coefficient is 2. So this is the formula. If you know this formula, you can easily solve it, okay. Let's solve now. So expectation value of LZ, it is going to be sigma I Ci mod square of Ci, right? So it is going to be this one 1 square for this into h cut. The value of m is 0 here, right? So 0 into h cut, we'll write in next page. So LZ is going to be this one coefficient of this C1, this is 1 square using this formula, okay, mod square of Ci, that is 1 square into value of m is, this is value of m, right? 0 into h cut, 0 into h cut plus for second it is sigma Ci, right? So it is 2 square into mh cut means m is 1, m 1 into h cut, okay, plus next one is 3, the coefficient this one, so 3 square mod of 3 square, this is 3 square, right? 3 square this mod 3 square mod mod square of 3 is 3 square, right? Same thing, so we are writing like this, and this is m, the value of m is here 0 into h cut, okay, 0 into h cut. One last one is the coefficient is root 2 whole square, root 2 mod square, right? This is the whole square, we can say same value into mh cut, value of m is minus 1 h cut upon this one sigma I mod Ci square, right? Mod square of Ci, right? So the coefficient square, this is 1 square plus 2 square, 1 square plus 2 square plus 3 square plus root 2 square, 3 square plus root 2 square. Okay, we'll simplify it. So it is going to be, this is 0 plus 4 h cut, this is 0, this is minus, right, minus 2 h cut, the square of root 2 is 2, right, and upon this is 1, 2 to the 4, 4, 9, this is 9, 4, 13, 14 to 16, right. This is LZ, and this is going to be 2 h cut, because 4 h cut minus 2 h cut is 2 h cut upon 6, and that is h cut upon 8. 2 will get cancelled 8 times. Okay, so value of LZ, the expectation value of LZ is h cut by 8. This is the answer, guys. Okay, let me check which option is matching. This one, option number D. Okay, h cut upon 8, option D, right, guys. Okay, so this is the question number 2. Now we'll solve question number 3rd. Okay, question number 3rd. Okay, next question, question number 3rd. This is the energy eigenvalues. The energy eigenvalues, the energy eigenvalues of a particle, values of a particle, energy eigenvalues of a particle in the potential, potential Vx equal to, it is also very good question, Vx equal to half, Vx equal to half m omega square x square minus ax. Okay, the energy eigenvalues of a particle in the potential, Vx equal to half m omega square x square minus ax are, options are given. Option number A, En equal to n plus half h cut omega minus a square upon 2m omega square, 2m omega square, and option B is En equal to n plus half h cut omega plus a square upon 2m omega square, okay. Option C is En equal to n plus half h cut omega minus a square upon m omega square, and option D is En equal to n En equal to n plus half h cut omega. Okay, these are the options which are given. Okay, so the energy eigenvalues of a particle in a potential Vx equal to this, you need to find out. Okay, okay, okay guys, so we're going to start solving the question. Solution is, so we know if Hamiltonian is for harmonic oscillator. Okay, Hamiltonian for harmonic oscillator, harmonic oscillator, we know, right, that is h equal to px square upon 2m plus px square plus 2m plus half m omega square x square. That's what we know, right, the Hamiltonian. And if this is the Hamiltonian for harmonic oscillator, then we know the energy eigenvalue, right? We know this energy eigenvalue En. If this is the Hamiltonian, if Hamiltonian for harmonic oscillator, we know px square upon 2m plus half m omega square x square. This is the potential energy, that is Vx, right? But here this is potential energy is half m omega square minus ax, not this one. Okay, if this is the one, in that case the energy eigenvalue is, we know, that is En equal to n plus half h cut omega, right? That's what we know. And now we will find the Hamiltonian, this, right, for this. But here the Vx, here Vx is given half m omega square x square minus ax is given, right? So we'll rectify it, right? So here, then in that case h is going to be, for this case the Hamiltonian is going to be px square upon 2m, because it's 1D harmonic potential, right? It is going to be plus half m omega square x square minus ax for this. Okay, for this, for given Vx is this, right? For this Hamiltonian is going to be this, right? Okay, so now we'll simplify it. This is going to be h equal to, we'll simplify it, so we can write px square upon 2m. Okay, plus this is 1 upon 2m omega square, which we will take common, and it is going to be x square minus 2ax upon m omega square. This is the one, right? This is going to be this. Okay, because we have taken this common, and this is the value. Now we'll write further. So this is going to be h equal to px square upon 2m plus half m omega square. We'll take common and we'll write this is x square minus 2 ax upon m omega square. So here we can do one thing, right? We can add for making perfect square. So we can do a square. We can add a square upon m square omega to the power 4. We can add, and also we can subtract uh, a square upon m square omega to the power 4. We can add and subtract. So if you do that, it is not going to change the expression. So it is going to be h px upon 2m plus half m omega square omega square. This is the very important step, guys. Okay, because we need to make perfect square so that we can get the answer. Okay, understand this. Okay, so this is going to be whole square, right? So we can write x minus a upon m omega square whole square. We can write, right, minus a square upon m square omega to the power 4. We can write this, right? This is the one. And now what we can do, this is h is going to be px upon 2m plus half m omega square. Okay, this is going to be x minus a upon m omega square whole square minus, so we'll multiply this with this. Okay, so this is going to be minus a square upon get cancelled, right, and omega square also get cancelled, so it is going to be 2m omega square, a square upon 2m omega square. So this is going to be this value, right, because we have multiplied this with this. Okay, this one, m get cancelled, omega square will get cancelled with this omega square, and then 2 will go here, right? This is one. So now we can write h plus, we'll take this right hand side. Okay, this is going to be a square upon 2m omega square. Okay, 2m omega square we have taken in right hand side, so it is going to be px upon 2m into plus half m omega square and x minus a upon m omega square whole square. Okay, this we can say. Okay, this one. So now this is going to be h equal to h plus, so what we can do, h plus 1, h plus a square upon m omega square. Let's say this value is s dash. Okay, and this value is x dash square, we can say. Okay, right. This equation is going to be now h dash equal to half m omega square x dash square. Okay, x dash square, where h dash equal to h plus a square upon 2m omega square and x dash equal to, this is this one, x minus a upon m omega square, okay, this one. So this now this one x minus a m omega square, okay, this is the x dash. So this again, this becomes in the form of like this, right? H dash equal to this one. This is here one more thing I forgot to write, which is going to be h dash equal to px square upon 2m plus half m omega square x dash square, okay, and these are the values. This expression we have, let's say this value is x dash and this value, this whole value is h dash, okay. So this became, in the form of like this, right? This one like this form, h equal to px square upon 2m omega square, like this form, right? So then energy eigenvalue is going to be, so for this energy eigenvalue is going to be E dash equal to n into, this is n plus half h cut omega, right? Then E dash is going to be in similar way like for this we have done, right? For this energy eigenvalue is this. So simply this is also in this form, h dash equal to x dash, right? Now we'll put the value E dash, the value of E dash, we'll put it, E dash is, this is E dash is this one, h dash, E dash equal to h dash, right? Eigenvalue. So this is E dash, the value is E dash is this one, h plus a square upon 2m omega square, right? H and E is same, right? So it is going to be this is h, right? This is going to, h is E plus a square upon this 2m omega square. This is going to be equal to n plus half h cut omega, and this implies the value of E dash, right? Value of energy eigenvalue, that is En, is going to be equal to n plus half, this is, we can write E dash, okay, En plus this. So value energy eigenvalue is going to n plus half h cut omega plus a square upon, this will be minus a square upon 2m omega square, okay. This is the answer, okay guys. So this is En equal to this one. So which option is matching? Option number A is the correct one, okay. Option number A is the correct one. So very simple question guys, but you need to practice this question. If you will practice, then this question is going to be easy, okay. Just you need to practice this question, okay. So we can easily find out En, okay. First because this potential is not in the form of half m omega square, right? This one, so we have converted this into this, so we have made perfect square and then we have made in this form, this one in this form. Then we know that En plus half E dash equal to this, and we put the value of eigenvalue, this is this one, and because h and En is same, right? Eigenvalue, this is the eigenvalue. So that's, from there we have taken this in left hand side, and this is the eigenvalues for this potential, okay. Okay guys, next question, question number 4 we are going to solve. Question number 4. Let me check the internet connection first. Okay, it's fine. Question number 4, okay. Question number 4. This is if a particle is represented by, if a particle is represented by, if a particle is represented by, is is represented by particle is represented by the normalized wave function, the normalized wave function psi x equal to root 15 a square minus x square upon 4a to the power 5 by 2 4a to the power 5 by 2 for minus a, x is between a and minus a, okay, and then x is between minus a to a, or 0 otherwise, okay, 0 otherwise. 0 otherwise, okay. So normalized wave function is given for the particle. Very good question. Okay, so the uncertainty uncertainty uncertainty, that is delta p in momentum, in its momentum is okay. Options are given. Option number A, that is 2h cut upon 5a, 2h cut upon 5a. Option B is 5h cut upon 2a. Guys, all questions are very important questions, okay. So learn these questions, practice and revise. C option is root 10 h cut upon a, and option D is root 5 h cut upon root 2a. Okay, so this is the question. Question is, if particle is represented by the normalized wave function is given, uncertainty in its momentum, that is delta p, we need to find out. Okay, so we'll solve it. Solution. So we are going to solve it. So we know that uncertainty in delta p, the formula, like delta p is root expectation value of p square minus whole square of expectation value of p. Okay, this we know. Okay, so one thing I would like to write here, okay, and please note down, very important, whatever wave function is given, the expectation value of p, okay, I'm not going to solve it because it's well known, okay, expectation value of p, you need to memorize it, guys, okay, very important. Expectation, whatever wave function is given, that doesn't matter, okay, expectation value of p is always going to be 0, and similarly expectation value of x is going to be 0, okay, and also the odd power of x cube expectation value, that is 0, x to the power 5, that is 0, similarly p cube, that is going to be 0, okay. So this is important, you need to note down. So expectation value of p is 0, so we don't need to find expectation value of p, we'll just find expectation value of p square. Okay, so we'll find expectation value of p square and we'll put the value of p square in this equation, and we'll find this uncertainty in its momentum. Okay, we'll find out delta p, that is delta p. Okay, okay, so we are going to start. This is going to be expectation value of p square we are going to find, so that is going to be psi p square psi upon psi into psi. Okay, this we know, right? Okay, so we are going to find it. So psi is given, that is this one, right? Root 15, this one, psi x equal to root 15 a square minus x square upon 4 a to the power 5 by 2. Okay, this is given. So we'll find out the expectation value directly. The expectation value of p square is going to be, this is going to be right in next page. This is going to be expectation value of p square. It is going to be integration, because it's a normalized wave function given, right? So it is going to be, so expect or we can, because it's a normalized wave function, so that means psi that is 1. Okay, normalized, that implies, okay, normalized. Okay, so this is going to be psi p square psi, difficulty in writing, so psi p square psi. Okay, and this we can write integration psi star psi dx, right? This is going to be integration, value of psi we know, right? And this one psi is given, this one or this one. Okay, between minus a to a, this value is 0. Okay, so this one, right? So it is going to, and there is no imaginary term, so psi star is also this. Okay, so this is going to be root 15 upon 4 a to the power 5 by 2, 4 a to the power 5 by 2 root a square minus, sorry, 5 by 2 a square minus x square, a square minus x square, a square minus x square, a square minus x square. Okay, then this is p square, this p, guys, p square psi dx. Okay, so we know p square equal to minus h cut square del square over del x square. Okay, p square equal to minus h cut square upon minus h cut square del square upon del x square. This is the value of p square, so we'll write minus h cut square this one. Okay, h cut square upon h cut square there is difficulty in writing. Okay, so this one, and this is del square upon del x square, and this one we'll put value. This is again root 15 upon 4 e to the power 5 by 2. This is a square minus x square dx. Okay, this is the value, and limit is minus a to a, because otherwise this value is 0. This one, right? Psi is given, normalized wave function. Okay, so this is going to be integration. So we'll take constant outside. So it is going to be this is 15 upon 16 e to the power 5. Okay, this will get multiplied and will take outside. Okay, and this minus is also come outside, so this is going to be minus h cut square, and this integration is going to be minus a to a. Will integrate it, right? So differentiate it with this. So this is going to be minus 2, right? So we'll write a square minus x square into, after differentiation, this term, this is going to be minus 2 dx. Okay, minus 2 dx. So okay, just wait guys, system got hanged. Okay, so next this is going to be p square is going to be equal to, we'll integrate it, right? So this is going to be, h cut square, this minus minus will be plus. Okay, this is going to be h cut square into 15 upon this one 15. Okay, 16 e to the power 5. Okay, and 2 is also there, so minus minus will into 2, because here minus and minus is going to be plus. Okay, and so this is going to be 2, and then we'll integrate it. So it is going to be a square x minus x cube upon 3 minus a to a, right? We have integrated this term, very simple integration. So it is going to be p square equal to, we put the value. Okay, this is going to be h cut square h cut square into 15 upon 16 a to the power 5. Guys, give me 1 second. Okay, this is 15 upon 16 a to the power 5 into 2 into 2a cube minus, after putting the limit, it's going to be 2a cube upon 3. Okay, so We'll simplify it. So this is going to be, if you simplify it, this is going to be 15 h cut square, 15 h cut square upon 4 a to the power 5. So this is a to the power 3 will become after putting the value, a to the power 3 sorry, this is 15 upon 16 h cut square into 2 upon a to the power 5. I will take 2a cube common. It is going to be 1 minus 1 upon 3. Okay, and we'll simplify it. So this value is going to be 5h cut square upon 2a square. Okay, 2a square. So this is the value of p square, guys. The expectation value of p square. So now this one, 5h cut square upon 2a square. So this is going to be, okay, this is now the value, that is delta p, uncertainty in p, delta p. This is going to be root p square minus expectation value of p, right? So delta p is going to be, this is the value of expectation value of p square we have already found. This is 5h cut square, 5h cut square upon 2a square, 2a square minus expectation value of p is 0. I have already explained. So this is going to be delta p equal to root 5 upon root 2 h cut a. Okay, this is the answer. Let me check the option, which option is matching. D is matching, right? So option D is the correct one. Option D is the correct one. Option D is the correct one. Okay, next question we are going to solve. This is also a good question. This is commutation relating to commutation property. Simple question. Okay, this is the answer. So next question, question number 5. Question number 5. Okay, so this is given the usual canonical commutation relation. Given the usual canonical commutation relations, the commutator AB of value of A is I iota xpy minus ypx xpy minus ypx, and and B equal to ypz minus zpy. Okay, this is given is this is xpy minus ypx and ypz minus zpy is. Okay, this you need to find out. Commutation AB you need to find out. Very simple. And options are given. Option number A is h cut xpz minus pxz minus pxz. Option B is minus h cut xpz minus pxz. Option C is h cut xpz plus pxz. Okay, and option D is minus h cut xpz plus pxz. Okay, so this is the question. So we need to find out commutation AB. Okay, so we'll solve it. Solution. Okay, so AB is going to be iota xpy minus ypx. Okay, this commutation is the ypz minus zpy. Okay, this commutation, that is A commutation B, we need to find. Okay, so here I'm going to tell you some properties for commutation so that it will be easy for you. Okay, I'll write this in red ink. Okay, so this is this property is if there is xpx, or these are properties of commutation, right? Or ypy or zpz. Okay, if this is the case, then the value is going to be iota h cut. Okay, if it's a reverse order like pxx equal to pyy equal to pzz. Okay, if this is the one, this is going to be minus iota h cut. Okay, and this property also you need to know. AB commutation C, this property is ABC. I'll use this property, guys, to solve this question. Okay, AB plus AC into B. Okay, the first property, or there is another property like A comma BC, that is commutation. This is going to be AB into C plus B into AC. Okay, these are the property I have written in red ink, right? Which I'm going to use it for this question. Okay, so I'll write the question now. This is going to be A commutation B is going to be iota xpy iota is outside, right? Xpy comma ypx this one, right? This one I have written here actually, this one. So we'll solve it. Okay, so this is going to be iota xpy. Just give me one, I'll write again. So this is going to be iota is common, so I'm writing iota together. This is iota xpx xpy, sorry, xpy xpy minus iota y px iota y px iota y px commutation. This one, the another is ypz ypz minus zpy. Okay, this one I have taken, I have multiplied iota with this, iota with this. Okay, so iota xpy minus iota ypx ypz zpy ypz zpy. Okay, now we'll proceed further. This is going to be iota xpy with this. Okay, ypz. Okay, this one will multiply this with this. This is one, then this with this, plus this is going to be iota, this is minus. Okay, minus will this minus iota y sorry iota xpy into zpy. Okay, plus this with this is minus again, and also guys I'll write here as well. This is also important. I'm going to write like z if we get, it is going to be 0 px py, this is 0 xpz. These terms are going to be 0. Okay, only if these terms are there, then it is going to give value. Okay, like this y px, these values are 0. Okay, so this is, now we'll multiply this with this, minus iota y px comma y pz. Okay, and this minus plus, this is going to be iota, will take common. Okay, iota, so in second term will take common. Okay, so this is going to be iota ypx comma zpy. Okay, this is the one. So next term we're going to write, so this is going to be iota will common, this is x py comma y pz. Okay, and these terms are going to be 0, 0. Okay, and this term minus iota will take common. This is going to be y px zpy. Okay, why we have taken only this term? Because here we can see px this wait, iota ypx zpy, okay, so we can see ypy, right? This will give value, and here uh, ypy, this is also going to give value. So that's why we have taken, and all else we have left it, because these values are going to be 0 using these properties. Okay, so next it is going to be iota ypx and zpy. Okay, it is going to be iota x. We'll open it and we'll use this property. Okay, iota x common, this is going to be py ypz, okay, we have used this property, and next term is going to be 0, because this is going to be these values. Okay, it is going to be ypz plus iota x ypz py outside minus iy px iota ypx zpy. Okay, zpy. This is the one, iota ypz, this iota yzpy. Just wait, this one, this term is correct, and this one iota x ypz py minus iota px zpy minus iota yzpy okay. yzpy. Okay, this one. So these two terms are going to be 0. This one, because there is xpz and there is py, so there is no like xpz, so there is no this type of term, right? Xpx or xpx or ypy zpy term. So these terms are going to be 0. This term will be 0, this term will be 0. Okay, so this is going to be iota x, this term will remain. This is going to be py ypz okay, minus iota y, this term. Okay, iota y zpy. Okay, this is, and this term are 0. Okay, this 0. Okay, Next again we'll open this YPZ, right, using this formula, this one. Okay, so this is going to be AB equal to iota x minus I h cut. We'll put the value. Okay, so this one will open it actually. So how we are going to open it, I'll show you. So this is going to be x. Okay, this one ABC, right, this one ABC, this is going to be ABC, AB into C plus BAC, right, this property we'll use it. So this is going to be PYY PZ, okay, plus PZ plus PZ PY, sorry, this is going to be, this is outside, right, this one. Okay, so this is going to be Y PY PZ. Okay, PY PZ is going to be 0, right. Similarly here Y Z PY, this term is also going to be 0. PY, okay, YZ is 0 because I've told you. Apart from these, PZ, Z, PZ all are going to be 0 apart from these two relations. Okay, so this one, so this is going to be YPY means IX YPY. This is minus IH cut. YPY minus IH cut, right? Minus IH cut PZ PZ. I will open this one as well, this one, this YPZ, and this is going to be minus YPY into Z. Okay, this is the one. So this is also 0, this value is also 0, YZ is there, so it is going to be minus minus iota is also there. Okay, minus iota, so it is going to be minus iota Z, this is going to be minus IH cut. Okay, YPY. Okay, so iota H cut, this one, so this value is going to be the next page. Right, this is let me check this one. Okay, iota YPY. Okay, this is plus iota H cut YPY. Yeah, here YPY iota H cut. Yeah, it is correct. So this is going to be, let's solve it. This is going to be my this is will multiply iota square is going to be -1 and minus plus, so it is going to be just 1, that this is H cut will take common, this is going to be XPZ, Similarly here, iota iota will multiply, that is going to be iota square. The value is -1, minus minus plus, right? H cut we have taken common, so it is going to be this is that is here, right? Px is here also, px, px. So this is going to be plus z px, z px, z px. Okay, so the value of AB is going to be h cut xpz plus pxz. Okay, pxz. This is the answer, guys. Now we're going to solve next question. Okay, this is long class actually. There is one more question remaining. So this is also very good question, but I think because lack of time, I'm going to solve the remaining question in next class, guys. Okay, this time is already over. Okay, now just let me check. XPZ. Okay. This one. X is outside. X is here. X, okay. That's why. Okay, guys. So these are the questions. So remaining questions we'll solve in next class. The next question is very lengthy because lack of time. I'm going to solve that question in next page, next class. That question is related to Schrödinger equation. Okay. So guys, thank you so much for watching my lecture. And also I would request the people who haven't subscribed my channel yet, please subscribe my channel. Okay, and enjoy my lectures which are free of charges and going to help you to crack the exams related to physical science. Okay, okay guys, thank you so much. Bye now.